Welcome back. Let's talk about tornadoes. Tornadoes are usually spawned by severe thunderstorms. They don't just happen on their own. So it's usually, rain, thunderstorm, severe thunderstorm, and then if the storm gets bigger, more energy, more intense, more violent, then it could spawn a tornado. Not necessarily, but it could. It's obviously one of nature's most violent natural processes. I mean, they easily make the news anytime one occurs. They're classified according to the most intense damage that they produce. So we rate them based on the damage, which helps us infer how fast the wind was moving, how fast the air was moving in the tornado. And the scale we use is called the Enhanced Fujita scale, or the EF scale. Now, in order for a tornado to occur, you need something called wind shear. And wind shear is different speed or direction of air in different layers of the atmosphere. Because of, for example, the ground and buildings. So this can actually slow down moving air masses, to where the further you go up into the atmosphere, the faster the air moves. So what these lines are showing you is that the shorter the line, the slower the air, the longer the line, the faster moving air. So because you have faster moving air in the upper atmosphere and slower moving air in the lower atmosphere, it kind of creates this tumbling effect. It kind of creates this tumbling effect with the air because this stuff is moving much faster than this stuff below, kind of overtaking it, causing this tumbling of air mass to occur. So that's how the start of a tornado works. So first you get faster air in the upper atmosphere, slower winds and air lower in the atmosphere. So you get this kind of barrel rolling of air. So you get this horizontal tumbling axis of air. And then you need some way for that material to be pulled up vertically. You need some sort of updraft. So you need, for instance, warm air to be shoved up, and it can take this tumbling mass of air. And if you start to just pull that tumbling horizontal mass of air upwards, so you get this horizontal mass of air, all of a sudden you get something pulling it upwards, and now you have this spinning column of air. But in this case, now you have formed a tornado. So that's kind of how it's spawned. It's a lot more complicated than that. But in general, that's how it works. Now, again, tornadoes are measured on the Enhanced Fujita scale, the EF scale. It's based on damage, and then the damage can help us infer how quickly a tornado is moving. So, if we see light damage, some damage to chimneys, branches broken, shallow-rooted trees pushed over, signs, like stop signs and stuff like that, damaged, then that would be an EF0. Maybe that tornado wind was moving 65 to 85 miles per hour. So then, you just base it off damage. Almost kind of like the modified Mercalli scale of earthquakes. But if we're looking at the strongest, the EF5, strong frame houses just leveled off foundations and swept away. Automobile-sized missiles flying through the air in excess of 100 meters. Trees debarked, just bark ripped right off the trees. That's an EF5, and that wind is moving faster than 200 miles an hour. In essence, EF0, least damage, EF5, almost complete in destructive damage. So where in the U.S. gets the most tornadoes? I'm sure from movies or any guesses in life. There's a place called Tornado Alley. So that Tornado Alley extends kind of from Texas up through the Central Plain states, Oklahoma, Kansas, up into Nebraska, Iowa, South Dakota, North Dakota. So that's an area called Tornado Alley, in which in certain locations, the average annual tornado incidence, is more than, for instance, in the darker red colors, more than 9 tornadoes per year, every year. which is a lot. I mean, hell, one tornado is too much for me. But you can see there is a little bit of blue in Arizona as well, meaning on average we can get about a half a tornado per year. So therefore, on average, we get one tornado in Arizona every 2 years, even in the Phoenix area. It's not uncommon, believe it or not. So how does all this work? You get this warm, moist air coming from the Gulf, where you have the first spawn a thunderstorm. You get cold, dry air moving from the north. You also get some warm, dry air, and all of these conditions, upper level movement of atmosphere, all of these conditions create a perfect storm, no pun intended, for tornadoes. What also aids in tornado generation in these areas is that the terrain is very, very flat, which helps with the wind. And then all of these three contrasting air masses, which create atmospheric instability and uplift. Warm, moist air, cold, dry air, warm, dry air, all this stuff is mixing. Big thunderstorms, which could spawn tornadoes. In 2020, there was a total of 117 tornado watches issued, meaning there's a tornado coming, watch out. And you can see the highest incidence is actually shifting to the south. Tornado Alley is typically in this area, but you'll notice that the higher red incidence, it's due to climate change. The number of tornadoes where they occur is actually shifting to the south. Same thing in 2021. You still get some in Tornado Alley, but the darker red colors indicate that tornadoes, the more prevalent tornadoes, are actually shifting more towards the south. 152 tornado watches issued in 2021. And then so far this year, again, Tornado Alley, somewhat gentle, but we look at the south. This is where the highest incidence of tornado watches have been issued, 69 of them so far. We can see that in number of fatalities as well. So 2019, so all of these are tornadoes that caused fatalities. So 25 fatalities in Alabama. So the lion's share. Louisiana, over here. Mississippi, over here. You get a handful in Texas and Oklahoma, but the vast majority are kind of in the south here. And a lot of those deaths are due to people living in manufactured homes, mobile homes. They're very light, flimsy material. Tornado rips through there. It's going to destroy the mobile home, kill whoever's in it, because it's ripping it all apart. Mobile homes are very cheaply made. It's ripping it all apart. Wood, metal, just tearing it to shreds. And so it's a bunch of shrapnel flying through the air, spinning around in the air. It's merciless. And so a lot of people who die in tornadoes end up due to the fact that they live in mobile homes, manufactured homes. 2020, 78 fatalities, 28 in Tennessee, 13 in Mississippi, 9 in South Carolina, 8 in Georgia, 5 in Alabama, 5 in Louisiana, some in 2 in North Carolina, and then in Texas, 4, Oklahoma, 2, South Dakota, 1. So again, you're really missing out on historically where there used to be a lot of occurrences and as well as deaths. A lot of that's shifting to the south. Again, a good number of people dying in mobile manufactured homes. And so far in 2021, we already have, that was not so far in 2021. So back in 2021, we had even more, 101 deaths, 73 of those in Kentucky, Alabama, Tennessee, North Carolina, again, in the south. Kind of everything's kind of shifting off to the south. In this case, in 2021, at least verified, 12 in manufactured mobile homes, 61 are unknown. My guess is a lot of that would get put into this mobile manufactured home category. Interesting to see what will happen in 2022. Probably more of the same in the south. So here are just some pictures of tornadoes. I think we all know what they kind of look like. Sometimes they're very skinny. Sometimes they can be a little bit wider. Sometimes, it's dark. Sometimes it's not. These are storm chasers. In fact, I think that's the same guy, as a matter of fact. So storm chasers, these are professionals that chase storms around. You can see how flat the terrain is. That's typically where you're going to get tornadoes. You can get it in, more varied topography areas, but typically long flat stretches are really what's going to help tornadoes spawn and grow and thrive and live. Sometimes they only exist for a few seconds. Sometimes they can go for hours. I guess it just depends on where they're going through. It's just the luck of the draw where this weather is moving through to. In any case, let's go ahead and pause here. When we come back, we'll talk about tropical cyclones. See you back here in just a second.